Department of Physics, RJ College, as well as IAPT Mumbai Sub Regional Council. And I'm very happy that we have a resource person who has actually taken initiative in starting this particular lecture series. Last week only, Vijay Singh sir said that let us start something during this lockdown period, since we are not able to do anything outside. And we immediately thought, and he accepted that I will deliver a first lecture. So thank you very much, sir, actually on behalf of all of us, that you have accepted to deliver this lecture. Coming back to his little bit introduction, Dr. Vijay Singh completed his doctoral degree from the State University of New York in 1978. He was a professor of physics at IIT Kanpur for over 20 years, that is from 1984 to 2004, and professor of physics at Homi Bhabha Center for Science Education, which is a center for TIFR, Mumbai, from 2005 to 2015. As well as he was an adjunct professor at Center for Excellence in Basic Sciences, Mumbai, and IIT Bombay. He is the fellow of National Academy of Sciences, visiting professor at CEBS, and currently the president of Indian Association of Physics Teachers. He was the national coordinator of Science Olympiads, a national initiative for undergraduate science, for about 10 years. Under his mentorship, large number of high school students and have won gold medals at international Olympiads. Also, large number of undergraduate students have completed and carried out their projects, resulting in several international publications. Professor Vijay Singh has worked as visiting faculty at universities in United States of America. He has over 150 peer-reviewed international scientific publications. He is a co-author of NCERT physics textbooks for high secondary physics, and he was also a chief editor for Indian Association of Physics Teachers Bulletin, which is published every month. And one of his hobbies is to solve and design problems at school and undergraduate level physics. I think that is a very unique hobby, and I can go on, but let us have Dr. Vijay Singh for the today's session. I welcome you again, sir, for this session, and over to you. I think our Devi Prasad Shetty will help you out if with your technical assistance, and you please start your lecture. Thank you once again. And sorry for the delay. Yes.
Thank you, Rekha, madam.
Should I begin?
Yes,
Yes,
sir.
sir, please.
Okay. Okay, a very good afternoon to all of you. And
Good
I would like to
afternoon,
begin by thanking, thank you. And I would like to thank Rekha and Jhunjhunwala College for coming forward to share this experience with us. Okay, I'm not a very savvy with modern technology, so I will do my best. I will try to speak slowly and deliberately. Okay, and the topic I've chosen is essentially something which is a very popular topic. So I thought to begin with, we should go easy on the students or on the participants, and they might be encouraged to participate and to attend even the other much better talks than this present one. So let me begin. The topic that I have chosen, where is it? I have to share the screen. Somehow I have to go to the application window. I know that. The topic that I've chosen is right here. It's called Physics and the City of Mumbai. As someone, and before I start, am I clearly audible, Devi Prasad ji?
Yes, sir.
Okay. And is the screen visible clearly?
Yeah, clean.
Yes. Yes, sir. Yes, absolutely.
Thank you. So now I can begin. Once again, it is Physics and the City of Mumbai. As someone who has lived and spent quite some time in what was once Bombay and what is now Mumbai, okay, it is natural, and so have many of you. Many of you have also been in Bombayite, if I might say, or Mumbaikar. It is natural to have a certain attachment and to have a certain perspective on the city. So just as a poet would write poetry about the city, or someone who writes novels would write a short story about Mumbai, as a physicist, we look at the physics of Mumbai. Okay, some 100 years ago, a poet had come from Lucknow. So since I spoke about poetry, I'll talk about what this poet did. He had come from Lucknow, and he went on top of Malabar Hill and saw the crescent, what is called the Queen's Necklace now, which is Chowpatty Beach, and he was very thrilled. Then he went to Worli, to Haji Ali, and he saw the crimson sunset, which I will now show you. And he
हाँ
wrote
जी,
a poem, a short diary about it. Okay.
क्या
And that
करें?
was, this is, yes.
नहीं अभी नहीं इतना आसान तो ले लेना। हाँ, क्या? हाँ देखा था।
Yes, someone wanted to say something.
Please, please mute all the audios.
2,40,000 तक है, ऐसा था?
Hello.
9 point something rate of interest है। अच्छा 17,000 कुछ किस जाएगी हैं? पता नहीं अब फायदा है नहीं, मेरे समझ में ये बात।
Sir, please continue.
Hello, Vijay sir.
सर को म्यूट हो गए क्या?
DP.
हाँ मैम, सर को अनम्यूट करना पड़ेगा। हेलो,
हाँ, just unmute.
रेखा, उनको फोन मैसेज कर, नहीं तो फोन डाल कि सर आप अनम्यूट कीजिए अपने आप को करके।
Is not allowing me. Vijay is saying, I have unmuted myself.
Okay, sir.
Now, can you see the screen?
We can hear, sir.
Can you see my slide?
Yes, sir.
Please. Yes, please.
Okay, only one person should speak, maybe Devi Prasad ji, so that would help me. Okay, so that is what this poet exclaimed. And when you look at this Haji Ali picture, what attracts you is the presence of this minaret. Okay, and you ask yourself this question, why is there a minaret out on the sea? Okay, so a minaret is actually, it acts as a lighthouse. A manara in Arabic means a lighthouse or a signaling tower at sea. Okay, so it is used as a signaling tower or a lighthouse so that ships from far can see you, can see that there is some land close by, and then they can get hard from this, from the fact that they've been out on the sea for such a long time. So now they have come to the shore. Okay, and why do you have a tall structure? That is because, well, if I can quote another Indian mathematician, Aryabhat, Bhugol Sarvatto Vritta, that is, the earth is round. That is why you have that minaret. That is the simple reason. It is what they call as the horizon problem. Okay. As you go higher up, it is the further that you can see. So let us, as a beginning thing, before we go into something heavier than this, let us look at how that happens. What happens is you use Pythagoras theorem. You just focus on this. The earth is round. You are up on a minaret of height h. So r plus h the whole square is equal to x square plus r square, where x is the distance to the horizon. Okay, and if you do that, and you simply ignore one term in this, which is h square, because h is 10 or 50 meters, while r is some 6,400 kilometers, you get this expression, x is equal to square root of 2rh. Okay. Now you take this expression, r is 6,400 kilometers, h is some 25 meters. If you're on Haji Ali, it's actually 25 meters. And you work out, excuse me, and you see that you can see approximately 18 meters away, 18 kilometers, sorry, as far as 18 kilometers away. So this is the kind of question every kid asks his parents, or his father or his mother. No, why is the horizon round? Why do we need a tall structure to see far? And the simple answer is this. This might look to most of us as something very simple, but it has buried in it a lot of very interesting physics principles. So let me recount that for you. One, okay, one, you ignore h square in terms of 2RH. Okay, so that is how to make an approximation. You teach the kid that. Two, okay, you teach the kid something called working with mixed units. R is usually in kilometers. The radius of the Earth, R, is 6,400 kilometers. H is usually in meters. It's like 25 meters. You can see it here in the calculation. So how to convert units? Three, you come across a scaling law. The scaling law tells you that you need not calculate square root into 2R all the time. You do it once and for all. 2 into R is 2 into 6,400 kilometers, which is 12,800 kilometers. Then you do it once and for all and put it aside. So every time you come across a new h, you just do the square root of h. So the third is a scaling argument, an approximation of h square. Number two, working with mixed units. And three, a scaling law, square root of h. And the fourth and the most important is the experimental one. Can you really see this far? And the simple answer is no, particularly if there is pollution, then certainly you can't even see 5 kilometers ahead. Okay, so what you have to actually decide then is, can you actually see this? Okay, what is the experimental or observational test for this? Is that clear? So this is what I would say as a beginning and an opening line for the city is would be my use of the Haji Ali Minaret and Pythagoras theorem, or the Silver Sutra as it is called. So before we continue, we are still on the introductory part of Mumbai. Okay, let me make a brief comparison between Mumbai and England. Okay, here is the comparison. The history of Mumbai. In 1661, or before that, Mumbai was with the Portuguese. The Portuguese Princess Catherine Braganza was married to the King of England, King Charles II. And as part of the dowry, and even they had the dowry system, it's not only we who can be accused of this. She took Bombay as a dowry gift to England. That is 1661. So we were being traded from one European country to another. Okay. And what was happening in the world is that around the same time, Robert Boyle proposed his Boyle's law for ideal gases. Pressure is inversely proportional to the volume if temperature is constant. In 1668-69, British East India Company leased, or they took, the East India Company is the biggest and most rapacious multinational company ever in the history of mankind. They took Bombay or Mumbai from King Charles II on a lease. Okay. Around that time, while we were being traded once again, the Philosophical Transactions of the Royal Society, the first peer-reviewed journal, came out in England. 1687, the British East India Company transferred its headquarters from Surat to Mumbai, making it head of all the company's holdings. What was happening in England at that time? Newton brought forth his great publication, the Principia, which had the laws of motion, the law of universal gravitation, and is actually the basis for all of classical physics. Let us go further ahead. 1802, a very important treaty was signed between the Marathas and the British East India Company, in which it's called the Treaty of Bassein or Vasai, in which essentially the Marathas gave up a lot of their rights, and certainly the rights to Mumbai or any other place, to the British. Okay, that was the final nail in the coffin of Mumbai. And around the same time, Thomas Young basically put forward the wave nature of light. So this is the way the world has continued. The comparison is stark. Okay, while we were being ground under the heels of colonialism, the world in Europe was making great strides. Okay, a little bit of the geography of Mumbai, with which we are probably familiar. The Mumbai consists of two places. I mean, basically there is suburban Mumbai, the green zone. Okay, and then there is this island city of Mumbai. Okay, right. The population of Mumbai is about 18 million. And I don't have to stress in this times of Corona, the population density is very high. It's upwards of 40,000 persons per square kilometer, which means that on an average, I say, on an average, each person has 5 meters by 5 meters to herself. And that's the average, mostly it is much less than that. Okay. So the population density is very high. The layout of Mumbai is not unusual. It is a layout for many cities across the world. Let me make another comparison now. This is Manhattan. Manhattan is also north-south, just like Mumbai is. Okay, it has long avenues north-south and streets across. It is any city which has rectangular roads cutting at right angles to each other. It's called the Manhattan metric. Okay. As opposed to that, a city which fans out from a central point, which goes out in all directions, okay, that is called a Moscow metric. Why Moscow? Because Moscow fans out from a central point called the Kremlin. Okay. Now, what are we? Mumbai, which I show on the left side, is the Manhattan metric, approximately a Manhattan metric. Okay, here is the island city. Here is Mahim, where I was born. Where I spent a lot of time. Okay, and this goes north-south. The streets of the major roads of Mumbai are north-south. For example, if you look at the Lady Jamshedji Road, it starts from Bandra and it continues on and on all the way to Kolaba, perhaps under different names. If you look at Muhammad Ali Road, the Muhammad Ali Road continues straight all the way down to Mankhurd. On the way, for some stretches, it's called the Ambedkar Road, and then it's called the Vianpura Road. You look at the Tulsi Pipe Road, what is called the Senapati Bapat Marg. It starts from Mahalakshmi, it goes all the way up to Mahim. It does get interrupted because of the creek, Mahim Creek, but then it continues again and used to be called, now of course, SB Road, but it was called Godbandar Road. Okay. So we are in the Manhattan metric. There are very few east-west connections. One is over Tilak Bridge, for example. Delhi, on the other hand, fans out from Connaught Place. So it's called the Moscow metric. Okay. So the first thing you ask yourself is, what kind of a metric does the city have? And what imposes that metric on it? And as far as Mumbai is concerned, it is basically the sea on both sides which imposes this north-south metric or the Manhattan metric. Okay. All right, so much for the introduction. And let me once more pause to ask, am I clearly audible?
Yes.
Hello?
Yes, sir. Yes.
And is this visible, the screen?
Yes, perfectly okay.
Thank you very much,
Yeah.
Rekha.
Yeah.
Okay. And I can also be seen, is that right?
Yes. And you're audible
Not
clearly.
very well. Okay. Thank you. So now if you're living in Mumbai for a decade or even more, there are some pivotal experiences we all have. Okay. So let us go over what, as a Mumbaiker, we always see or we experience all the time. Okay. One of the experiences is the Mumbai trains. Okay. Not running anymore. So it's no more a topic of perennial conversation, whether the train is late, the train is not late, and how many people, basically board the train, how many people are late, which is the busiest section. So the Mumbai trains is one of them. It's a landmark of Mumbai. Perhaps when this COVID-19 crisis blows over, they will come back to their own. Okay. The first train, a little bit of history, okay, just a little bit before we do a couple of physics with it. The first train was from CST, Victoria Terminus in those days, to Thane. That was a long time ago, 1853. It went 34 kilometers. It was a steam engine. It halted at a few places, basically Baikal and Sion, and it took exactly 1 hour and 15 minutes for the journey. Okay. The fast train today, maybe takes about 45 minutes and 4 halts. And the slow train takes 1 hour, 15 minutes less than what our earliest train in 1853 did. Okay, so that's if you would like to call that progress. The progress is, I would say, 1 minute for every 10 years. We have cut down the timing from 1 hour 15 minutes to 1 hour. Okay. There is something about trains which I have to tell you also. Okay, there is just the history of trains and how slow our progress has been. Okay, the speed of a fast train is approximately 90 kilometers per hour. That, as physicists know, is 25 meters per second. We like to work in SI units, and therefore we say how many 36 kilometers per hour is 10 meters per second, and we translate it to 25 meters per second. Now, you ask yourself the following question. Supposing you're on the railway track, okay, and there is a fast train coming, and for some reason you are incapacitated. You fall down, you cannot get up because you have broken your knee bone or something. The question is, would you be saved? Okay, would the train driver be able to stop the train in 100 meters? The answer is no. Okay, try 200 meters, try 300 meters, 400 meters, and even half a kilometer. Which one of these would be a safe distance to fall, you would ask. That is the kind of question I'm asking you. I'll pause for, say, 10 seconds so that you can think of an answer. Okay. Out of these, 100 to 500 in units of 100 meters, which one would be a safe distance? The answer to this is none of them. None of these, because the maximum deceleration of the train can be only half a meter per second square. This is an important number, and you plug it into a very important formula that you learn in 9th standard. Okay, v is the final velocity, which is 0. U is the initial velocity, which is 25 meters per second. You stick a half into the 2 and you get 1, and therefore you get S is equal to 25 square, and that is 625 meters, more than half a kilometer. So half a kilometer is not sufficient, and you have not even considered the reaction time of the driver, the time it takes for her to see you and then step on the brakes or to apply the brakes. That would be another 2 seconds, and that would be another 50 meters gone, and that would be 675 meters. So never ever cross the railway tracks. I am told that even now about 10 people die on the tracks every day when the trains are running. I don't know how many get injured, but at least there are 10 fatalities almost every day. So let me continue with another theme. This theme has to do with Bernoulli's principle. Can you stand near the tracks? It is not safe. And the answer to that comes from the fact, for the same reason that planes fly. That is because when planes fly, the wings are so shaped, and they're so aerodynamically shaped that the velocity below is higher than the velocity above. Okay, I'm sorry, it's the other way around. The velocity above is greater than the velocity below. So if when the velocity is high, okay, the pressure is low. Okay, so so above the pressure is low, below the pressure is high, and the plane goes up. Okay, a simple way to understand it also is to say that when a movie hall ends, once again, there's no movie halls anymore during the Corona crisis. when the movie all ends, everybody rushes for the outside. And at the door, there is a higher pressure, there is a smaller velocity. As soon as you edge past the door, you are again open, there's low pressure, high velocity. Okay, so that is one reason you're advised not to try stand before or close to the railway tracks. This is a no. You should never do this. Okay, because when the train flies by at high speed, there is a small, it drags the air with it. Very much like if you're going on the Bombay-Pune highway, okay, then on that highway, if you're in a small car and a big truck passes you by, you feel a lateral pressure towards that truck. Similarly, you will feel a small perceptible pressure towards the railway track. Okay? And this could prove to be a dangerous thing for you. Okay? So never do this. The third thing you never do in a railway, for as far as the railway trainers or the local trainers concerned, is the following. Okay, let me show it to you. And the principle of, here we apply the principle of angular momentum conservation. Okay, it was Bernoulli's principle earlier. It was kinematics. Now look at this. This is August 18th, 2018, 7:18 p.m. at Thane station. Hamid Jiwal's fatal deboarding from a local train. The train was streaming in this way. Okay. Hamid Jiwal tried to jump off that train while before it had stopped. It was not moving fast. It was moving slow. But he tried to deboard while it was moving in the opposite direction to the motion of the train. And as soon as he landed, he fell onto the platform and he injured his skull. There was blood and he was no more. This was reported in the newspaper with the statement saying that we don't know who this person is. It was 2 days later that it was found that Hamid Jiwal had come from Bangladesh. He was far, far away from his country, from his parents, from his family when this tragedy happened. Okay. Deboarding a local train while it is moving is also fatal. Okay. How do I explain it to a student? What I will say is the following. You are alighting from a moving train. Do not look at this picture. Look at this picture. Okay. The train is moving at a speed of 2 meters per second. Okay. It is moving with 2 meters per second. So it is basically the train is moving like this, say to the left. You are alighting. When you jump off the train, you have an angular momentum. That angular momentum is mass into velocity, which is the momentum. It is the same thing in this direction because this train is moving at the speed v. So you carry the speed of that train. You carry the momentum of the train. So your speed is m into v. And the angular momentum is the distance from the platform to half your height. L is your height. Say you're 2 meters. You're a tall person. So you get mvl by 2. Okay. When your feet hits the ground, and it's right here, okay, when it hits the ground, it is, you're no more moving, you're not moving translationally. You will now rotate about this point. It is like coming like this. You start rotating, and for that, you use I into omega as the angular momentum. I've written W, read that as omega. The moment of inertia I is ml square by 3. That's the moment of inertia of any rod about an edge point, not about the central point, but about an edge point. Now you put 2 and 2 together. You equate this angular momentum to this angular momentum. The mass would cancel out. It doesn't matter how heavy you are. You're a heavy person or a light person, doesn't matter. The L cancels out and you get omega is equal to 3 by 2 V by 2L. One of the L's cancel out. Okay. So V is about 2 meters per second. It's a slowly moving train. So you are under the fake impression or the false impression that I'm safe. It is just 2 meters per second. So 2 and 2 cancels out. L is 2 meters. So 3 by 2 is about 1.5 radians per second. A radian is about 60 degrees. So it is 90 degrees per second. Imagine what that means. This means that you fall down in 90 degrees. You fall 90 degrees in just 1 second. So you cannot save yourself, and neither is a bystander who's looking at this tragedy intervene to help you out. Okay. So we could go on and on. We could continue with the strain physics, and it is quite fascinating, I can tell you. But let me shift gears, okay, and talk about something else. So we did kinematics, okay, and we did, how should I say, Bernoulli's principle, and then we did angular momentum conservation, mechanics. So let's go ahead, okay. Let's go to something else, the Bombay rains, for example. This is the Bombay rains. What you see in front of you is a scene. This scene is from July 26th, 2005. Okay. The scene basically tells you that there was a huge flood. You can see these floods. It's actually quite, how should I say, terrifying to see this. Lots of people walking. Okay. We have all experienced the Bombay rains. Okay. Who has not? Every monsoon, in spite of our precautions, there is that one day we forget to take our umbrella. It's a clear day and we get wet. We all get wet. Okay. Also, we all manage to lose 1 or 2 umbrellas per monsoon season. So we know the monsoon, it's about to come. It should have arrived by now. But this is how the 2006 tragedy played out, at least in a small, I should say, a small sideshow, but an important, a very tragic event happened. We were told that during these rains, the cars were underneath water, half covered with water. And the people inside were not able to open the door. Okay. They were not able to open the door. I wondered at that time if this is true. Until I actually did an experiment of this type, I was not convinced that they could not push the door open. Okay. So you see, look at this door. The door is half underneath water. And each door, for example, which is underneath water, let us say it is 1 square meter. And what you do is use a very old principle due to Pascal for the average pressure exerted by the water on the car door. Okay. The pressure exerted by a fluid like water is not always downwards. It is exerted equally in all directions. Okay. The pressure exerted on the door is given by the height of the door, which is say 1 meter. Like G is the gravitational acceleration, which is 10. So this is G, H is 10. And rho, the density of water, is 1000 kilograms per meter cube. That works out to 5,000 Pascal. Okay. Very high pressure. Okay. This kind of a pressure exerts a force on the door because pressure into area is the force. The area of the door is 1 meter square, and therefore the pressure is the force on the door by the water outside is 5,000 meters. How much you as a human being can exert? It is not difficult to see. How much can you lift? You can lift at 20 kg. You can lift 30, at the most 1,000 kg, which means 1,000 into 10 is, say 100 kg, you can't lift 1,000 kg. 100 into 10 is 10. So 1,000 Newton is the maximum that you can give from inside. And from the outside, the water is relentless. It has got 5,000 Newtons versus 1,000 Newtons. So unless you can open the window, okay, which you could not because some of them worked on electronics and the electronics jammed because of the floods, you are trapped. So the reports that we heard that a few people died because they could not open the doors of their cars is probably true. Okay. Okay. The third issue. Okay, I've gone through, it's been about half an hour. So I have another 15 minutes, 30 minutes, 15 minutes at least till 5 o'clock. Okay, look at the third issue. What is the third issue? We have a housing problem. Okay, everybody and his brother is an expert on housing. Whether you are a peon or a professor or a panwala, everybody is an expert. You want to buy a house, you just have to say, or you want to sell your flat, even if you don't, a very interesting experiment you can do, you can just announce outside that I want to sell it. And you have all kinds of people approaching you. This is Mumbai. That truth. This is Mumbai. These are basically what is called the slums or the jhopadpattis of Mumbai. They go by different names in different countries. In Rio de Janeiro, which is also having a corona crisis, it is called favelas. Okay. In Azania, South Africa, they are called shanty towns. In US, they are called ghettos, okay, where there is an uprising right now. And in England, it's called slums. In Bombay, it's called jhopadpatti. Housing problem is very acute. How do we solve the housing problem? I have no answer. Okay, if I had an answer, I would apply that answer and make a lot of money. There's no answer, but I can understand the problem. So I will take you by a circuitous route to an understanding of this problem. Okay, here is the Church of Mayhem. I'm not sure if it is the Don Bosco Church or the Mayhem Church. It's one or the other. Okay, and what you see on the side is basically the Don Bosco Church is in King Circle, by the way, and the Mayhem Church, of course, is in Mayhem. Okay, St. Michael's Church. These large windows that you see, the function of these windows is very simple. They let light in. They let nutrition in. If you didn't have the windows, this entire area would be quite dark and you would need electricity, a lot of electricity to actually light up this place. Okay, so basically what happens is that you have cells. You know, if there's a cell, the cell has to divide, because as it grows bigger, the surface area goes as 4 pi r square, as r square. The volume goes as r cube. The nutrition comes from the surface, like this light, and to support that volume of r cube, the cell better divide, because the ratio of r square to r cube, 4 pi r square to 4 pi by 3 r cube, is 1 by r. As r becomes large, the cell becomes unviable. So there's a constant struggle to increase the surface area. You might say, what has that got to do with the housing problem? Bear with me, indulge me a few minutes, and I will explain it. Okay. Same thing. You see this modern malls. Again, these are closed nowadays. Okay. There is a big, this is called the atrium, by the way. Atrium means heart. What you see upstairs is basically a huge dome, which is lighted, which is not lighted, but it's transparent. So it lets light in. Since it lets light in, the people in the mall or the people who run the mall don't have to use too much electricity. Okay. Here is our small intestine. Okay, the small intestine is not small, it's 22 feet and it's all coiled. Why do we do that? Because it actually sucks in nutrition, that the food we eat, it sucks in the nutrition from it. Okay, so it has to have a large surface area. To increase that surface area, it does something very interesting. On the inside, it has hair-like protrusions called villi. Okay, and these are all on the inside lining of these small intestine. That increases the surface area even more. In fact, the modern bath towel is inspired by these villi. Okay. The earlier one was simply a piece of cloth which would not dry you. But because of these small hair-like protrusions, which the modern bath towel has, now you have better drying capacity after you take a bath. Lungs are also in the news now because the lungs are getting filled with water if you are a corona patient. They have a large number of air sacs called alveoli. Why is that? To increase the surface area. Okay. Here's how you deal with increasing the surface area. What do? You go into the third dimension, as you can see here. Or you look here. This is a modern airport. How do you accommodate many planes? There's not too much surface area, but you think of villi. or these hair-like protrusions in your small intestine, and you have what are these called air jetties. Okay. At this point, let me pause for a minute and ask again, one of you, am I clearly audible?
Yes, sir.
Yeah?
Yeah, it's perfectly okay. Yeah.
And is this visible?
Yes, your screen is also visible very
Okay.
clearly.
Thank you.
And yeah. Thank you, sir. Yes.
Okay. So what you do here is the following. Here is a very innovative example in Dharavi. This is from Dharavi. If you want to dry papad, okay, if you did it on a flat surface, you could accommodate 10 papads. But if you do it on a curved surface like this, you can accommodate 20 of them, because you are going essentially into the third dimension. So you go partly into the third dimension, and that is the idea by which you solve pressing problems such as the housing problem. How do you do that? Here it is. Look at the skyline of Mumbai. Okay, this glittering skyline. How have we solved the housing problem? By just going into the third dimension and accommodating people into the third dimension. Okay, so this is neither one-dimensional, nor is it fully two-dimensional or three-dimensional, or in three-dimensional, but it's between 2 and 3 dimensions. This is called a fractal dimension. Look at the skyline of every country which is an island, which has an island city like Beijing, or like Shanghai, or like Singapore, or like Tokyo. All of them have similar skylines where you go into the third dimension to actually accommodate people. And that is not the only thing. Here is another example. Our double-decker BST bus. One deck is not sufficient, you go into the second dimension. Look at our local long-distance trains. The third class sleeper, okay, or what is called a second class or something, it's got 3 deckers, 1, 2, and 3. And here is a typical scene. I don't recommend this. There's no place here, so we go into the third dimension. Not recommended. So you solve the problem by going to a higher dimension, but how much can you solve? Okay. There is another example. There is a fruit. It's called, I think this might be the kadam, similar to the kadam fruit. You know, the kadam fruit, in case you have never seen it, or you must have heard at least, it is the kadam tree, is the tree on which Lord Krishna used to sit as a boy and play the flute. So it has hair-like protrusions like the corona. And it has these protrusions to increase its surface area. So the name of the game is increase the surface area or you divide. Okay. Let me change gears again. Okay. I've talked about the Bombay trains. I've talked about the Bombay rains. I've talked about the Bombay housing crisis. And this is just a side topic. So let me talk about the sea link. Okay. There is an interesting optical phenomena associated with the sea link. Okay. And that is, if you go on that sea link from the north side, that is from the Bandra side, you will see that this double-stranded cable-stayed sea link, this is called the cable-stayed sea link, and there are 2 strands to it, 2 parallel strands to it. They will show a very interesting pattern of this type. There's 1 strand in front and 1 below, and therefore, it will show you these very interesting patterns. And these patterns keep shifting as you keep approaching those double strands, and then they disappear. So once more, as you go on the sea link from the Bandra side, look up, look at these cables. And as you look at these cables, you will find these patterns which keep shifting. These are called Moire patterns. Okay. Because 1 strand is slightly shifted from the other strand, you get these patterns. Okay. Here is another example. You take this, in fact, you take a graph paper if you want. Take a graph paper. Okay, if you have something like this, it's even better. Take a transparency Xerox of it and move one across the other. As you move one across the other, you'll get these interference patterns. These are actually space patterns. These are actually called Moire patterns. Very interesting patterns. Okay, they are used to detect imperfections. If you take one and move it slightly against the other, you start seeing the pattern. Okay, and there is a very interesting history about it. The Moire patterns were used in, I would say, around 1890 to make storybooks, where you could make Jack, like a lion run or something in that storybook. And I'll show you an example here. I don't know if it'll be. This is a basically a well. Let's see. This, you see this penguin here. This penguin is here. Okay, and here is the Moire pattern on it, on this one. As I move it across, you'll see the ball flipping across. Okay, and you can purchase it at street corners, particularly at traffic signals, for 25 rupees. Or even in second-class compartments. Let me see if I can show you another one here. Here is some dolphin Moire pattern. Okay.
Sir, will you please switch on your video?
What is it? Hello? Say that?
Sir, your slides are not moving. They are stuck on slide number 39 or 40. 40 पे अटक गया है वीडियो.
हाँ, अभी मैं भी रोका हूँ.
नहीं, you were talking something else that let me show you, but we didn't see it. That's why I'm saying.
Now,
can you see
41.
this?
41.
Yes, now it is saying. Right? Yes, yes.
Correct. Okay. Because I stopped at that point. Yeah. Okay.
So you were showing something probably on your video, but your video is off.
Oh, my video is off. Okay. Very interesting. It is off. Amazing. I didn't turn it off. I can't turn it on. Now is it on?
No, because you are sharing your slides, we can't see you.
Oh, that's
no, it is on. It is on now. It is on.
Can you see me?
Now we can
see.
Yeah,
we can see you.
Okay. So what I was basically showing you is this thing that you buy for 20 rupees at at many traffic signals in Mumbai from street vendors or urchins. So here, can you see this dolphin? Yes or no?
Yes.
And then I put this pattern in front and I move it. You can see this dolphin moving up and down.
Yes.
Maybe you can't see
changing the pattern.
Yeah, by just changing a pattern. And they were used in the 1890s to make, before what I would say the Chalchitra came, the silent movies. These were used in as full storybooks to show how Red Riding Hood is moving and then how Red Riding Hood is being eaten by the wolf. Okay. Here is something that I have never succeeded in Mumbai. This is two high rises next to each other, and this is the sunrise. So I was trying to see if I can picture this or photograph this to get interference or some kind of a diffraction pattern, and it is not possible, I found. Okay. Since we are on optics and interference, I thought I should tell you this. Okay. So let me change a little bit again, change gears, and talk about a great institution in Mumbai. Now, think of a great institution, scientific institution of Mumbai. Okay. And I will tell you about one of them. Bombay is associated with many great institutions, and we look at one of them. Before we look at them, okay, here is it. It's the Colaba Observatory. It was built in 1826. It's the magnetic observatory which keeps a record of all the magnetic records and its fluctuations day after day, month after month, year after year. It has faithfully kept this record, I think, since 1840. Only place in the world which has an uninterrupted record of the magnetic field in the world. Even England and the Greenwich Laboratory or France, they have an interrupted record, interrupted by the First and Second World War. This is uninterrupted. Okay. And there's a great hero associated with this uninterrupted record, whom I'll tell you about. Let me backtrack and tell you about the trams, and then I will come to the trams are relevant to the story. Okay, the trams of Mumbai. Okay, this is a very old picture, and I hope you can all see it. These are trams drawn by horses. It was around 1870, 1880. Okay, all kinds of trams: single compartment tram, three compartment tram, double decker tram. You can see the double decker, all kinds of red tram, white tram, and all kinds of trams. Okay. The great thing about trams is what I would call as the romantic era of trams. Okay. The great thing about trams is that it is end point pollution is zero, so it is not polluting. There is level boarding. Look at this gentleman over here. I remember when I was a small kid, I could hop on and off the tram because it was low and it was a level boarding thing. It's good for old people and children. Okay. It moves slowly. It goes into the heart of the city. Okay. So small shops and businesses are assisted by the tram. It, as opposed to cars, which you drive into malls. Okay. And if you have been to Dubai or something, you have to drive 20 kilometers to get to a mall or something like that. Here too, you have to drive to get to a mall. Trams go into the heart of the city. They would go right into Kolaba market. Okay. So I would call that the romantic era of trams. And talking about trams, and I'm really sorry the trams, the life of trams in Mumbai ended around, I think, 1962. Okay. Here is another thing to highlight this romance. All the way, there's an All India Music Conference. When was this? January 27th to February 1st, a long time ago. This is 1942 or 1943. Somehow the date is not here, but it is somehow buried somewhere. This is an invitation to attend trams, this music conference, where some of the greatest singers sang, from Aladia Khan to you name it. I mean, it was a, and it says book early to avoid disappointment. Look at this red thing, and trams available after every night performance. So they said, if you attend this, this was somewhere in the around Rajabai Clock Tower or somewhere in South Bombay, and after that they say trams are available. I thought I should just share this very, very old and very historic music conference that was held in India or in Mumbai a long time ago. You see the names which are associated with it. People like Omkarnath Thakur is right here. Aladia Khan, of course, is here. And all kinds of great singers. In fact, I have to stretch my eyes, but you can see them. Okay. So I said the trams, I bring out the romance of the trams, but there's now the story. I have to get back to the physics, okay, from the music. Okay. The British introduced trams around 64, 73, 1864, I mean, and they were drawn by horses. There was a proposal to electrify trams in 1900. But it was delayed till 1907 because there was an objection. There was an objection. And what was the objection? The objection came from the Kolaba Observatory. The objection came from the, how should I put it, the director of the Kolaba Observatory, Mr. Moose, Nana Boy Moose, who said that I will not allow trams because there will be overhead cables. Okay, not allow electrified trams. Horse trams are all right. Electrified trams are a no-no because I'm doing these magnetic observations, these currents, the stopping and starting of trams. Yes? Okay. All right. So they said that it will disturb the magnetic field measurement. So you cannot do it until I allow you to do it. And while they waited, while the British waited for 7 years to introduce electrified trams, what he did was he did suitable observations in Alibag and in Mumbai and in Kolaba, did a calibration study, built an observatory in Alibag, and shifted his observations, observing instruments all to Alibag. Okay, there is some physics behind this trade, but let me not get into it, except to tell you that when a current flows, if there's a high current like 20 ampere, a surge of current, A 20 ampere current is not common, but if there is a surge, you get basically a change in about some 0.0004 Gauss, which can disturb the recording. The recordings went up to 0.0001 Gauss at that time. Okay. Hence, the trams were not allowed in the Colaba region until the observatory shifted to Alibag. Okay, and this is Colaba. I will show you Alibag, which is right here, which was in the eye of the storm, Nisarg storm. Okay, and first you did the calibration studies in both places, calibrated Alibag, and then you moved from Colaba to Alibag. Okay, and there's also another interesting history about every brick that was used to build the Alibag Observatory was tested for magnetism to see that it doesn't have any kind of magnetic signal. Okay. It was at that care that it was built. So as I said, associated with tram is this great Colaba Observatory. Associated with Colaba Observatory, there's a great lesson where the director of an institute would stand up to the government. Not common at all these days. I've seen directors of even big institutions keeling over and bowing to the powers that be. Okay, this is the magnetic observatory at Alibag. So of course, before I leave and go to the concluding part of my talk, 5 more minutes or 3 more minutes, I have to show you something else, and that's another great institution in Bombay, 1883, the Bombay Natural History Society. Okay, right. From between 1911 and 1921, they did a great survey of species, mammalian species in India. And I think they collected about 50,000 species and about 100 new one among them. Okay. It was a great exercise in what is called Citizen Science Initiative. It's a voluntary body like the Indian Association of Physics Teachers, and they undertook that task a long time ago for mammalian species. Okay. Okay. So finally, you can't stop. If you have to discuss Bombay, you have to discuss Mumbai, you have to talk about Bollywood. Okay. And we all know that many of the things that are shown in Bollywood are simply not allowed because it won't happen. Okay. The hero would die if he tried that trick, particularly, for example, here's this one. The car is moving in one direction, this hero is getting off in the other direction. Like Hamad Jawal, he would just crash his head and he would be dead in 1 second. Okay. Here is a guy who's walking vertically. Here is a person who is falling through a waterfall. None of this is possible. A person casually crossing the tracks when the train is approaching at high speed. Okay. So we know this is not possible, so I'm not interested in it. No, there are people who make a career out of this to show why this is not possible or why it is possible. There's a gentleman in Germany who does this for James Bond movies. Okay. What I'm interested in is in the romance part of it again, like the trams. Okay. Here is a great scene from Mughal-e-Azam. It's called the Shish Mahal scene. 1,000, maybe 10,000 small mirrors were put up on the roof and on the sides by K. Asif, the director of Mughal-e-Azam. Okay. To create the scene to show Madhubala in each one of them as she danced. She danced to this great one-liner called Parda nahi jab koi khuda se, bando se parda karna kya. When my love is not hidden from God, why should I care about you, Emperor Akbar? And then at that point, she's shown in all these thousands of these kaleidoscopes. It's a kaleidoscopic effect. It is made with Belgian mirrors, but these Belgian mirrors were not made in Belgium. They were made in Firozabad. And the set was made in, I believe, in Mehboob Studio in Bandra. It's a great kaleidoscopic effect. There's another one I want to show you. There are at least 5 or 6 optic scenes that I have from movies which are just wonderful, Bollywood movies, but I can show you only one of them and explain the physics. Here is one from a movie called Bajirao Mastani. It's called the Aina Mahal scene. Bajirao is standing here. Someone is explaining to him how this is happening. There is a mirror. There is a reflection from that mirror onto another mirror, which is in water, and that is reflected onto a screen. How do I produce this effect? Not difficult. This is not a difficult effect to produce. You have an object, say Bajirao, you have a concave mirror, you get a reflection onto a plane mirror if you want. In her case, there was another concave mirror here, and that plane mirror then projects onto a screen. Okay. And I would suggest to all of you that if you're interested, you can actually show it. I mean, I have something, but I cannot show it now because of this mode of operation. I normally try to show how this is possible. Okay. So with this, I think I will end. There's one more final scene. You know, this is a Pani Puri scene from a movie. And the question is, how much water is there in this Pani Puri? So we actually bought some 50 Pani Puris from different sources, measured, and of course ate those Pani Puris, 15 cc. So if you take 6 of them, you put nice water in it, you put some, how should I say, pudina, etc. It's a good remedy, oral rehydration therapy. ORT as it is called, Bombay style. Take 6 Pani Puris. Okay. And with that, I will end. And thanks to you for listening to this. Thank you very much.
Yeah.
Okay.
Any questions, participants, please?
Am I visible? Okay. Stop sharing. Okay, I've not stopped sharing. Yeah. Okay.
Yeah, now you are visible.
I've stopped sharing.
Yes, sir, you are visible.
You have to speak a little louder. Wait, maybe my volume is low. Okay, so I'm done. So if there is any comment, there really shouldn't be a question. If there's a comment, you can say something else about Bombay. That.
Yeah. There is a question from actually YouTube. Hello.
Yes, I can see. What if the water fills the car from the inside? Then you are home. Then there's not much of a problem. Then you can open it. Okay. Thank you.
Okay. Anybody else?
Somebody has another insight, I would like. You need not necessarily have a question. You can say add something, some value to this talk, if you want, by adding your own observation. Sir, you did not think about this. Or you didn't tell me. I thought about.
Professor Vijay Singh, I want to say something.
Boliye.
I thought you would tell us that why the camera did not show up in the Sheesh Mahal scene in Mughal Azam.
Why did the camera not show up in the Sheesh Mahal scene in Mughal Azam?
Yeah, because that was a big tussle between the movie photographer and the other people. That how can he avoid camera showing up? Then he does this in the mirror room. But it turned out we couldn't spot camera or anybody else. It was just the actress.
Madhubala.
Yeah. So
that is an interesting question. I haven't thought of it. To be honest with you, it's a very good question.
Yeah.
Do you have any answer? I mean, you have any plausible?
No, I don't know. You showed it, so I thought maybe you would answer it. So I was just waiting for it.
No, actually, at one point I thought of it, but I don't know the answer, to be honest.
Yeah, that's fine.
Very good. I'll think about it. So there's something to think.
We read so many articles on this particular thing, but nobody ever talks about the reason why they could avoid
difficulty, very important difficulty for the camera person. Okay.
Yes.
Very good point. I was also very intrigued by the fact that it's only Madhubala who showed up, in all those Belgian mirrors, Belgian glasses. So, बड़ा मुश्किल रहा होगा. There is sir, the Mumbai local are sometimes little bit tilted while arriving at the station. Is that because of very much crowd in it? I wouldn't think so. Usually when you go around a curve, there may be a small tilt. Okay. I don't think the crowd would be the source of it, because if it did, and a much higher crowd, and the thing would just tilt over, which is something you always worry about. So no, it's just the tracks are such. No, I don't know if you have seen. I think it is someone called Sakshi, but just for your knowledge, if you have time today, you look at a YouTube in which Feynman is speaking. Feynman is speaking about how you negotiate a curve because those two wheels are supposed to be essentially of fixed length, no? And then when you have to negotiate a curve, the distance between in that curve, the distance increases. So how do they manage this? Is a very interesting question. There's a tilt over there. Okay. I can't go into the detail of it, but if you click on Feynman, okay, and train or something like that, you'll see this.
Actually, everyone is fascinated by Mahesh is asking, is it possible that Madhubala was seeing camera and camera was seeing Madhubala? So camera was out of field of view itself.
I don't know. I really have no idea. No, there's not much description
I think your last slide has made a lot of impact. It appears like that.
I see. Everybody wants to eat pani puri.
Yeah.
Maybe the pani puri, the one before that, or the Aina Mahal or Madhubala.
No, actually, under normal circumstances, we would go for a pani puri after this class. But with this corona situation, we are deprived of it.
Okay. Yes. Yeah, I know. We used to. I'm now that I've shown that scene, I want to have a pani puri myself. Okay.
Yeah. There is, sir. There is question from, or maybe it's a comment. Sushma Mane, she is saying informative, wonderful, etc. Shalini Kushwa, thank you, sir. And there is one question from Vijay Chavan.
Yes.
The Kulaba Observatory was shifted to Alibag. Did the Kulaba Observatory stop running after that?
No, they still had their offices there. In fact, the director used to sit there. Okay, in Kulaba Observatory. The instruments, there were some elementary instruments in Kulaba, but the main ones were in Alibag.
Okay.
Then the Kulaba Observatory shifted. I don't know if they still have that space to them, but now it is shifted to IIG, Indian Institute of Geomagnetism, near Panvel.
Okay. There is one more from YouTube, Anurag Mishra, MSc student, physics student from Christchurch College, Kanpur. My question is to you that can we understand anything in physics, especially quantum mechanics? Simran Verma, everything, something is different. Simran Verma is saying, it's a different question. Simran Verma is separate. Everything and everyone in nature is governed by Newton's laws, but we still have weather unpredicted, irregular results in our practicals and probabilistic theory for a die. Lack of physics or technology? That is a question from YouTube.
Let me say about the first question. How about, what you can, I think the question should have been more like, you have talked about Mumbai and you have looked at it from classical physics viewpoint. You have not looked at it. Is there any quantum mechanical effect that you can talk about by simply looking around, right?
If
you look around Mumbai, when I talked about the horizon problem, I talked about Bernoulli principle. These are all classical effects. I mean, basically, classical effects are those that are easily seen. If you are actually moving around like a common Mumbaiker, these are the things that you would notice. Quantum effects are usually not very apparent. So I'm sorry to disappoint you, Anurag, but regarding Simran Verma's question, I think it is well known that even in classical physics, if you have a very large number of particles, there is unpredictability because you cannot crank out Newton's laws of motion for all these particles. That's why you need statistical mechanics. That's why you need probabilistic theory. And weather is the extremely predictable thing because it's an enormously complicated many-body effect. Classical many-body effect, not even quantum. You can see I have a book here called Quantum Many-Body Theory. Okay, let me pull it. But am I not moving? Somehow I'm not moving. Can you see me moving or not?
Wait a minute, sir.
In my, when you see me.
No, it's freezed, but we can hear you, sir.
Okay. For some reason, it is frozen. I don't know why.
Now you are moving now.
Okay, I'm moving now. I'm glad I'm moving.
Yeah.
So talking, moving, I don't know. So basically what happens is earlier there was only moving and there was no talking in the Harishchandraji factory. Okay, but now I was talking but not moving. So yes, it's a many body effect.
There is a question from Dr. Maushami Mohanty.
Mm.
Nowadays, trams head running with electrification, then how magnetic fields head managed?
No, so there is a magnetic field. It's very small. It's about 10 to the minus 4 Gauss, okay, or 10 to the minus 3 Gauss. Even if you get a very high surge and current, it will be 10 to the minus 3 Gauss, but it's certainly less than that. But there is no magnetic observatory close by. So let there be a magnetic field. In fact, you'll be very surprised. I don't know if Maushami is from Bombay, but there is a station near Grant Road, between Grant Road and Bombay Central, where the trains actually shift, into the yard. And there is a huge surge in current that could be recorded in Kolaba, even with their more rudimentary equipment. In fact, they could say now the local train has arrived in Grant Road or something. So that it doesn't bother them because their real observations are in Alibag where there is no disturbance. Okay. So उसमें कोई दिक्कत नहीं है.
Yeah. There is
And
no...
then trams, can they be brought back? Actually, I wish they would. Okay. Now I'll tell you something interesting about trams. It has no end point pollution, but you can argue that it will have pollution in the beginning point, no, somewhere in Igatpuri where you're generating this electricity or something. But the point is, thank you, Mausime. But the point is, in Melbourne, for example, they have brought trams back and they're bringing it back with solar power panels. So there's no beginning point pollution, there's no end point pollution. They run slow, they are gentle, they are good for small business.
I think that answers another question from Tushar Pandit also. He is asking, is it possible to start again the trams in Mumbai city? And what modification needs to be implemented for the benefit of humanity?
Well, it is.
I think, Mumbai.
Well, we have metro.
Yeah.
We have started metro now.
Yes.
So again, metro won't have an end point pollution, but metros, of course, metros are good because they'll have short stations, stations in about half a kilometer to a kilometer. So it is good for small business.
I think we are done with the questions.
There is one question. There is one question there by Simran Verma, which she has put. Why the point where sunrise or sunset changes every month?
What is it? Why the
sunrise or sunset changes? The point where sunrises or sunsets changes every month.
Okay, Mahesh, you can answer that. Or you should at least.
It's astronomy question, so my.
Yes. Now, why don't you answer that? Yeah, I'm not being facetious. I think you would be better. Why does it happen?
Sir, please answer because
नहीं,
will be interested.
नहीं, आप ही बताओ यार, क्यों होता है?
Because Earth's axis is tilted in one direction, and as it moves from one point to another point, I mean, over 6 months, you see the sun effectively shifting above the equator or below the equator, and because the sunrise and sunset is happening because Earth rotating about its axis, so you naturally see that during summer sun shifts towards north, so it rises north of east and sets north of west, and in winter it will be rising south of east and setting south of west, because it will be moving parallel to equator and it's a apparent motion.
Correct. So I think you've answered it well. Okay, thank you.
Yeah, I think we are done with the questions now. And the program is conducted on behalf of, jointly on behalf of Department of Physics, RJ College, and IAPT Mumbai Sub Regional Council. I request IAPT Mumbai Sub Regional Council President Dr. Atul Modi to present vote of thanks now. Atul, sir.
Yes. It's always very interesting to listen to Professor Vijay Singh. Very enriching experience as usual. So, sir, on behalf of all those people who have attended your session today,
Hello.
yes, I am requested to start my video. So on behalf of all those participants who have attended today, on behalf of all the members of Mumbai Sub-Regional Council Executive Body, and on behalf of RJ College Physics Department, we thank you very much. And IAPT also extends thanks to RJ College for co-hosting this program. Thank you very much, sir.
Thank you.
Thank you. Thank you very much, sir. Thanks a lot. Yeah. Yeah.
Okay, so
we end the session here. Yeah. Just yeah.
When is the next session? Can you announce?
Yeah, yeah. I will announce.
Feedback poll.
Yeah. So participants are requested to actually say the feedback and okay. Hello. Let me just announce here that IAPT Mumbai Regional Council and Department of Physics RJ College has actually announced this series twice a week, and every Tuesday and Thursday we will be meeting you with a new enrichment lecture, and next lecture will be on Tuesday. We shall notify you through some WhatsApp groups or the mails, and then regarding what is going to be the session. So till then, I say bye-bye to everyone and see you on Tuesday, coming Tuesday, that is on 16th. This lecture is going to be by Dr. R. Ganesh from Ahmedabad. And we will come with the details as a form of a notice. So
every lecture, I think we are going to put a new poster and new ID.
Yes, yes. So definitely the participants will get this notification and watch out for that. So thank you everyone. And I thank even my principal, Dr. Himanshu Davda, and Dr. Usha Mukundan, our academic director of Hindi Vidya Prachar Samiti. They were throughout attending the lecture, spent their valuable time during this time. And thank you everyone. Thank you everyone who has
Thank you, madam.
Thank you. Thanks.
Namaste.
1 minute. I should thank Devi Prasad Shetty from the bottom of my heart. I think without him, this session would not have been there. So thank you, DP.
Thank you, ma'am.
Thank you. Thank you. Thanks a lot. Yeah.
I will end the meeting now.
Yes, yes. We will end the meeting. We will end.
आपल्याला तरी कळलं का सध्या तरी तुम्ही 24